On our first lesson, we are going to review monomials and polynomials and exponent rules. So for our first part, our vocabulary word, a monomial is a constant variable or the product of numbers and variables. Notice the only operation that we're given is just the product. So we're not talking about adding, subtracting, or really anything of that notion. We're talking about one single term. So a constant value, that could be something like 1/2, maybe -3. Those are constant terms. A variable, well, we could say x, or we could say 2x. And now a product, of course 2x would be a product, but we could also talk about something like 1/2 x squared y cubed. That is a single term. That is a monomial. Even though it has a lot of stuff built into it, that would be considered, again, as a monomial. Use the exponent rules to simplify monomial expressions. So we do need to review our exponent rules. This is something that most everyone tends to forget, so we definitely need to go back over those. It's not like you use them every day. So let's see, the first one, let's say if we had x raised to the a power, and we're multiplying that in the product rule here, x to the b power, then my rule tells me that I can just add my exponents in this case. So that's going to be x to the a plus b. And an example of that, let's say we had 3 to the 4th power times 3 to the 2nd power. Well, our base is going to stay the same. A lot of people want to put 9 or 6 for the base. That is not going to be the case. Leave the base 3 and just add your exponents. So that's 3 to the 6th power. Okay, our power rule tells us if we had x to the a and we're raising that to the b, then this is going to be the product of a and b. That's what our exponent changes to. So here, a great example, let's say we had y to the 6th power raised, all of that raised to the 2nd. According to our power rule, that tells me to multiply 6 and 2, which is going to give us 12 most days. Now our quotient rule, that's going to talk about when we're dividing. So if I had x to the a power over x to the b power, then that's all going to simplify to be x to the a minus b. So a good example of that is going to be, let's use our 3 again. Let's say we have 3 to the 7th power over 3 to the 4th power. That base is not going to be 1. The base is still going to be 3. And then we're going to say 7 minus 4, which is 3. And remember, it is the top minus the bottom. It's always the top minus bottom. Now, if we have a negative exponent, let's say we have x to the negative a, that's going to be the reciprocal. It's going to say 1 over x raised to the a power. Notice we did not change the sign of the base. You don't change the sign of any of it. You are just going to find the reciprocal. So here, 2 ways we can use this. One way, if I had, let's say, 2 raised to the negative 3, that's going to be 1 over 2 to the positive 3. Or the other direction, you could have 1 over, let's say, 4 to the negative 1. So then that's the same thing as saying 4 to the positive 1. So this reciprocal goes both directions. You have to pay attention to where the negative is at. Now for the zero exponent rule, that's telling us that if we have some number x, we raise it to the 0 power, that is going to give us 1. Now we have to be careful here because our base, that x, it cannot be 0. So I'm going to put here in parentheses that x cannot be equal to 0. because then we get 0 raised to a 0 power, and that creates black holes and all kinds of mess. So we stay away from that. A nice, neat example of that is going to be 4x cubed. And notice all of that in parentheses, then raised to the 0 power. So all that gobbledygook goes to 1. All right, let's go through some examples using all of these rules. So here for our first part, notice we have a -6 raised to the 4th power. Now that negative is not inside parentheses, so we are going to just bring that negative down. And so 6 to the 4th power, I know y'all do that every day, you know. I'm going to go ahead and tell you it is 1296. So then bring down your negative. So we have negative 1296. And then times, so I'm going to bring my parentheses here. And we have -1/4 squared. Now this time we have parentheses, so that tells me that's going to be positive. And 1/4 squared is the same thing as 1 squared over 4 squared. So that's going to be 1/16. Now I'm multiplying a whole number and a fraction, so I'm going to put the whole number over 1. And that 16 will cancel into 1296, and that's going to leave us with -81. Okay, moving on to the second one. Again, let's work out, we've got a couple of options here that we can do. It is up to you which way you choose to do it. Now here, a lot of times I go ahead and I take that exponent and I multiply it to these other exponents. So that's going to get rid of my exponent on the outside. So I'm going to have 5 to the 0 times -2. Well, 0 times most anything is 0. Over, and then 3 to the -1 times -2. That's 3 to the +2. And let's go ahead and simplify that. 5 to the 0 is 1, and 3 to the 2nd, that is 9. So here we get 1/9. Now I do realize we can type these in our calculators, but we really need to make sure we understand what's going on with this first. And once we get a good understanding of it, then by all means we'll use our calculators. Right, so for number 3, the first thing we'll do is multiply our -3 and our 8. In most days that's -24. And then I'm going to multiply p to the -2 times p to the 6. So over here to the side, notice you're going to have -2 plus 6. So that's going to give me p to the +4. And that's going to be my answer there. Now number 4, let's not freak out looking at number 4. We can do some simplifying first. We need to simplify this very first term right here. That needs to be simplified before we do anything else. So let's see, 3 divides into 57. Let's see, 1 with 2 left over, so 19. Yes, I just old schooled that. 19. And here we're dividing one like basis, so subtract your exponents. So 4 minus 1 is 3 most days. And then y, same idea, but let's go over here because these negatives get us confused sometimes. We have -2, well, I don't know why I made that parentheses. All right, -2 minus, and then that's -3 in the bottom. So that's really plus a positive, isn't it? So -2 plus 3, that's going to end up being a +1. And whether or not you write the 1, I don't care. That's up to you. Okay, now that we've got that term reduced, let's bring down our minus and our 11x cubed y. Now notice that these are like terms. You've got an x cubed and a y and a y. So we can go ahead now and subtract 19 and 11. So 19 minus 11, that most days is 8. And then we just bring down our x cubed y. Here you're just adding or subtracting your terms, so there is no need to do anything with those exponents. Okay, moving on to our next problem. And oh my goodness, this has more letters than the alphabet here. Let's see what we got. you've got this stuff going on. I would not do anything with that until I simplified this. So I'm going to bring 3/4 r to the negative 2 s to the 5th, move that down, times. So that 2 needs to square everything inside here. So that's going to be negative 4 squared, which is going to be positive 16. And then we have r to the 3 times 2. And s, that's a positive 1 there, and 1 times 2 most days is 2. Now that we have the parentheses and exponent cleared up, now we can go through and do some multiplying. So the first thing I need to multiply is 3/4 and 16. So we're going to have 3/4 times 16 over 1. And we can do some canceling here, or you can multiply straight across and divide. I really don't care which one you choose. So we end up with 12. R, we're multiplying with like basis, so we add our exponents. So negative 2 and positive 6, that's going to be r to the 4th. And then s, multiplying again with like basis, so that's going to be s to the 5 plus 2, which is 7. All right, our next problem. We just have really one major term here to simplify. So the first thing we need to simplify is 18 over 42, and it looks like a 6 will divide out of both of those. So I'm just going to draw a fraction line. I'm super lazy. I know this negative is still going to be here. And let's see, 6 goes into 18 3 times, and into 42 7. Now notice we've got a and a, and let's see, it's going to be a to the 8 minus 5, which is a positive 3. So we're going to put that on top, a to the 3rd. Now look at what happens with our b's. Again, it's top exponent minus bottom exponent. So that's going to be b to the negative 3, which means reciprocal, or that negative, let's just smack it on the bottom part of that fraction, and you are done. Alright, moving on to the next set. And again, however you wish to simplify, work through, that is up to you. Let's see, I would probably, this is just a terrible mess on the inside there. So let's see if we can't clear up. Let's see, 39 and 24, those are divisible by, looks like 3. So I'm going to go ahead and simplify on the inside first. Again, I'm lazy and I like to do a lot of extra if we can help it. So if we divide these by 3, that top is going to be 13, and 3 goes into 24, 8. So I know that's simplified. And again, C, this is going to be 7 minus 2, so that's 5. 5 is positive, so it's C to the 5th on top. And D is 4 minus 5, which is negative 1, so that means D is on bottom. Alright, now we're ready to simplify here with this exponent. So we really just need to square everything. So 13 squared is 169. C to the 5th raised to the 2nd. Multiply those exponents, so that's C to the 10th. Over, and don't forget to square the denominator. That's where a lot of people tend to make mistakes. 8 squared is 64. And D raised to the 2nd power, just D squared. Alright, moving on to the next one. And again, looking on the inside of number 8, there's nothing that we can simplify here. We've got just m's and n's. So it looks like we might have to go ahead and use our exponent here. And if we go ahead and multiply through with that exponent, well, 1/2 raised to the 3rd is 1/2 times 1/2 times 1/2, which is 1/8. And m, we're going to multiply our exponents here, so negative 6, and n to the 9th. And then times, oh dear, we're going to make this all to the negative 2. So if I take this fraction, this 1/8, and raise it to a negative 2, it does two things. One, it changes 1/8 to just 8, and then 8 squared is 64. So that's a two-parter there. We don't have a fraction anymore because the exponent is negative, and that means reciprocal. And then we square the 8 to get 64. Right, so now our m, that's -1 times -2, so +2, and n to the -8. Now, it would be great if we were done, but we're not. We have to continue, so let's put together what we can. 1/8 times 64, that's going to give us just 8. Hopefully I can multiply. Right, so now let's look at our m's. M to the -6 times m to the second, that's going to be m to the -4, which means reciprocal. So that means m to the 4th has got to go in the denominator. And then our n, we have n to the 9th times n to the -8. And so when we add those exponents, we get n to the +1, which means it stays in the numerator. Alright, so now we're going to talk about polynomials. And the polynomial is the sum or difference of many monomials, and the highest exponent of a polynomial is called the degree. Yes, you need to know that. Why do you need to know that? Because in college algebra and the ACT says you have to. So sorry. Now, for standard form, if you want standard form, you are going to be writing, so you'll write exponents in descending form, or a descending order, however you want to state that. Okay, so here you're going to be writing those. Now let's look at our classification and then compare that to our number of terms. If you have a degree 0, then that is going to be a constant. And if that's a constant, then that's your monomials. That's what we've been talking about. It didn't want to work. Alright, so for one term here, that's going to be linear. And with linear, most of the time you see that as binomials. If we're talking about factoring and that stuff, that's where you're going to see a binomial. 2 terms is going to be quadratic. And with quadratics, you usually factor trinomials. Okay, and with 3, I think we called that let's see, with 3, we called that cubic. And let's see, with our cubic, we also, let's see, that's just more than 2 or more than 3 terms, so we call that polynomial. Because polynomial, N-O-M-I-A-L, polynomial means many. And then under the polynomial, you had your cubic, and then 4, that's your quartic. And 5 is going to be your quintic, Q-U-I-N-T-I-C. So there's your classifications, and again, if you talk about a classification by degree, there's your degree. And then if you talk about classification by number of terms, you have monomial, binomial, trinomial, and then that all goes into polynomial. Again, carrying on with the review, hopefully these things do look familiar. If not, that's okay. Just work through them. It'll come back to you. Now, again, this is also on the ACT, and notice what it asks you to do. The first thing you're going to do is simplify all of this. Then you need to write your answer in standard form. Remember, standard form means exponent descending form. And then you're going to classify this. So let's see what all of this is. So the first thing we need to remember is that if we just have a plus sign in front of the parentheses, we really can pretend the parentheses is not there. And we can combine these. So I have 1b squared here, 8b squareds here, so I have a total of 9b squareds. Here I have 5b's. I have -2b's here, so I have a total of +3b's. And then I have a -11 and a -7. So signs are the same, so I keep that sign and I add. So that's going to give me 18. So now I have simplified now let's go through and let's classify this. Well, if we classify it by degree, notice the highest degree is 2, and what we just saw was that if we had the highest degree of 2, this is going to be a quadratic. So we have a quadratic, D-R-A-T-I-C, goodness. And then how many terms do I have? 1, 2, 3. So this is a quadratic trinomial. I don't guess we need a comma there. Force of habit, folks, sorry. So let's get rid of that. All right. So again, all of these we've simplified, and then we classify according to our degree and number of terms. So let's move on to number 10. See if we can do very similar, the same thing, same process. So now though we have a minus sign in front, so remember that changes the signs of everything following it inside the parentheses. So we have a 3w squared minus a positive 3w squared. Well, that's going to be 0 w squareds or no w squareds. So those have canceled each other out. And now let's look at positive 2w minus 7w. So minus 7w, so that's going to give me a negative 5w. And then we have negative 6 minus 9. So that's going to be a negative 15. All right, so we've got all of our terms combined. And notice our highest degree. The highest degree that we see is 1, so that means this is linear. And then how many terms do we have? We have 2, so this is a linear binomial. All right, let's continue on, and hopefully you remember combining terms. Let's see, let's go through here, and we have a negative 3y squared minus a 4y squared. So negative 3 minus 4 is going to be a negative 7y squared. And let's see, a positive y cubed minus a negative 3y cubed. So that's going to be a negative 4y cubed. And I'm noticing here this exponent is larger than this one. So we're going to have to rearrange that to get it in standard form, but let's finish collecting our terms first. We have a minus 2, but I don't have another term to go with that, so I'm going to bring down minus 2 and minus y. There's really nothing to go with that. Now this is not in standard form, so I need to make sure I change this around. So I have negative 4y cubed minus 7y squared minus y minus 2. Now I have that in the correct form. Our highest degree that we have is a 3, so this is cubic. So I have a cubic, and we have 4 terms, so that's going to be polynomial. So I have a cubic polynomial. All right, so let's move on to our last one. And again, a lot of collecting terms it looks like. So I have a 5k cubed plus, and I don't have another k cubed, so I'm just going to bring down 5k cubed. I have a square. I have a negative k squared and a positive k squared, so that goes to 0. And we have a positive 7 and a positive 2, so that's going to give me a positive 9. And then it looks like I still have a minus 4k there. So looking at this, I don't have it in our standard form, so let's rearrange it. We have 5k cubed minus 4k plus 9. So now it's in our standard form, and let's go ahead and classify it. So my highest exponent is a 3. So this is cubic, and we have 1, 2, 3 terms. So this is a cubic trinomial. Okay, let's review some of these monomial operations here, or polynomial operations, excuse me. Now this is going to be our distributive property here on number 13. We're going to multiply this out. The first thing we need to do is take that x and multiply it to every single term over in the other parentheses. And remember, we are multiplying with like bases, so we would be adding those exponents. And now that we've done that, we come back with our -3 and we multiply it to every term. So that's going to give us -6x squared minus 18x plus 21. And now we need to combine our like terms, put together what we can. So we have 2x cubed. Our positive 6x squared and negative 6x squared will cancel. And we can put together -7 and -18. So that's going to be -25x plus 21. So now we've simplified it now, and we need to check to make sure we have written this in standard form, and we have. So now let's classify this. Our highest exponent we see is a 3, so this is cubic, and our number of terms is 3, so it's a trinomial. So it's a cubic trinomial. Okay, moving on to our next problem. The first thing we need to do is multiply this out, either distributive property twice or full, either one. So if I multiply this out, I'm going to have 20t squared, and then I'm going to have positive 12t minus 5t, and then minus 3. And then I'm going to take this -2t and multiply that through. So I'm going to have -20t squared plus 18. Now let's go through and combine our terms, and notice that our 20t squareds do cancel out. I have positive 12t minus 5t, so that means I have 7. And 7 plus, oh, I left off my t there. 7 plus 18, that's 25t, and then minus 3. So notice that out of all those terms, I ended up with just 2 terms. Now the highest exponent I see is a 1, so this is going to be a linear because of the degree is 1. And then I have 2 terms, so it's going to be a binomial. So it's a linear binomial. Okay, moving on to our next problem. Now this one always gets folks. That 2 means that there's 2 of them side by side here. And most of the time kids just go ahead and rewrite 4j minus 7k out here to the side. That's perfectly okay. And now let's multiply this out. So I'm going to have 16j squared minus 28, because again I'm multiplying this 4j to each part, so minus let's see, 28jk, and then let's come back with -7k multiply, so that's going to be -28kj, and then positive 49k squared. And then we need to combine our terms. So when we do that, we have 16j squared minus 56jk plus 49k squared. And so when we go to classify this, then we have, let's see, the highest exponent is 2, so we have a quadratic. And now let's see how many terms we have. We have a quadratic trinomial. Alright, moving on to our next problem. Oh, 3 parentheses, goodness. So we'll multiply 2 and then multiply the other 2. So let's go ahead and multiply the first 2. So I have 4v squared minus 6v plus 6v minus 9. And notice these will cancel out, so I'm going to go ahead and say, well, those cancel, so I'm really left with 4v squared minus 9, and then bring down our -3v plus 1. Now let's go ahead and multiply that out, and we're going to have -12v cubed plus 4v squared plus 27v And then we have minus 9. So let's make sure I didn't mess up a sign or anything. That looks pretty good. And so our highest exponent we see is 3. So we have a cubic, and we have 4 terms, so it's a cubic polynomial. Alright, moving on to the next ones. Alright, so again, still a lot of multiplying here, but we need the practice for our ACT and upcoming stuff. So let's see, multiplying through, we have p to the 4th. Oh, my pen has decided to quit. It's protesting this. Alright, so we have p to the 4th. And then we have minus 2p to the 3rd plus p squared. Now let's come back with this middle term and multiply it to every single term. Okay, so we come back with positive p multiplied, so we have positive p cubed minus 2p squared plus p. And now we're almost finished. Let's take negative 6 and multiply that through. So negative 6p squared plus 12p minus 6. Now let's see if we can combine some of these terms. And let's see, so the first one, we have p to the 4th, and I don't see anything to combine with that. Okay, so p to the 4th. Now p to the 3rd would be next. So let's see, we have minus 2p to the 3rd, a positive p to the 3rd, so that's going to be minus p to the 3rd, and we're finished with those. Positive p squared, negative p squared, negative 6p squared. Oh my goodness, so when we put those together, it looks like we have negative 7p squared. So those cancel out. And then maybe minus, let's see, no, positive 13p. And then I don't think there's anything to go with that, 6. All right, now our highest exponent we see is 4, so this is going to be quartic. And we have more than 3 terms here. We have, or more than 4 terms here, so that's going to be a polynomial. All right, same process with the next problem. Oh my gracious. So let's see if we can't get that multiplied out. So let's pick on this one first, and then we'll pick on this one, and then we'll multiply them together. So if I multiply out this one, I'm going to have 9x squared plus 6x plus 1. If you multiply all that stuff out, and then over here on the next one, you're going to have a positive x squared, a negative 8x, and a positive 16. And you can verify that over to the side, or you can work that out in your head, either way you want to. Now let's start multiplying this stuff out. So I'm going to have 9x to the 4th minus 72x cubed. And let's see, plus 9 times 16 most days is 144. And that's going to be x squared. Okay, coming back, our next term we're going to have is a positive 6x cubed minus 48x squared. And let's see, 6x times 16 is 96x. And then we've got just one we're going to multiply here. So I'm going to say plus x squared minus 8x plus 16. My gracious. All right, now that we have all that, let's combine our terms. 9x to the 4th. That's the first one. And let's see, our x cubes, when we put those together, it looks like we're going to have 66 maybe. Yeah, 72. So negative 66x cubed. 144x squared, negative 48x squared, and a positive x squared. So that looks like that's going to give us 90, so 97x squared. And then putting together our x's, looks like we're going to have plus 88x. and then plus 16. And again, to classify this, then it looks like our highest exponent that we see is going to be a 4. So this is going to be a quartic polynomial. All right, now on for the word problem. All right, so our last example, it tells us a triangle has a base of 3x plus 7. Well, it'd help if my pen wrote. Sorry, folks. 3x plus 7 and a height of 5x minus 1. A second triangle is drawn with the base that is tripled and the height that is doubled. Find the difference between the area of the original and the area of the new. Let's swap this because that's going to give us a negative area because the new triangle is much larger than the old triangle. So here, I think she has, when she typed this up, it was a typo. Let's say the difference between the new and the old. That way we get a positive area. All right, so let's see. Area of a triangle, we do need to review that. And again, this is something that comes up quite a bit. You are expected to know that. And so I'm going to go ahead and give it to you this one that y'all commit this formula to memory. It's pretty important for you. All right, so let's talk about the original or the old triangle. Okay, so the first triangle, that area is 1/2 the base, which is 3x plus 7, times the height, which is going to be 5x minus 1. All right, so let's see. I'm just going to leave that 1/2 out here. I don't like working with that if I can help it. We've got 15x squared, 3x, and 35x. So 32x minus 7. And I'm going to leave that there because that 1/2 times all that, I don't want to deal. Well, we could. Let's go ahead, though. We could just do 0.5. So half of 15 is 7.5 x squared. Half of 32, I don't know why I put 3 there, bless us. So that's going to be positive 16x, and then minus 3.5. I'm running out of room. All right. Now let's talk about the second triangle, and I'm going to slide that over here. All right, the second one, let's see, that is tripled, so I'm multiplying 3 here. So let's see, that area, I've got 1/2, triple that, so 3 times each part there is going to be 9x plus 21 times, and let's see, what about, let's see, the height is doubled. So if the height is doubled, I'm going to multiply that part by 2, and that's going to give me 10x. I'm going to have 10x minus 2. So that's going to give me 1/2 times, let's see, 90x squared plus 192x minus 42. Okay, and if we do half of each one of those, that's going to give me 45x squared plus half of 192. Let's see, half of 192, 96, sorry, I'm a little slow today in my brain. So plus 96, and then minus 21. All right, so now I need to know, well, what's the difference in the two? So I need to know, well, what is 45? We're going to take 45x squared plus 96x minus 21. And that's going to be minus 7.5x squared plus 16x minus 3.5. So if we subtract these, it looks like 45 minus 7.5, we're going to have 37.5x squared 96 minus 16, that's going to give us 80x. And negative 21 minus a negative 3.5, so I'm going to have negative 17.5. I think I'm running out of room. Let's see if I can slide it over. And that should be 17.5. That's probably off the screen.